Okay, today we're going to work on the perimeter and area of regular polygons. So the first thing we're going to do is review the polygon names. So we know that if it has 3 sides, it's a triangle. 4 sides, it is a quadrilateral. 5 sides is a pentagon. 6 sides is a hexagon. 7 sides is a heptagon. 8 sides is an octagon. 9 sides is a nonagon. And 10 sides is a decagon. After that, with the exception of 12 sides, really everything's just an engon based on the number of sides that you have. So then we want to talk about the radius of a polygon. It's the distance from the center to a vertex of a regular polygon. So we go from the center to one of the angles, and that's a radius. We also have something called an apophthegm, which is the distance from the center perpendicular to one of the sides. So that is an apophthegm. So to find the area of a regular polygon, we're going to essentially break this into congruent triangles. So I'm going to go to the next page so we have a little more space to work. Okay, so we have an octagon that has a side length of 8 centimeters. The hexagon that has 6 sides, not 8 sides. So the perimeter is going to be easy to find. It's just going to be 6 times the side length, which is 8. So our perimeter is going to be 48 centimeters. Now, to find the area, we're going to have to do a little bit of work. Essentially, we could break this into 6 congruent triangles. Okay? So what we're going to do is look at one of those triangles. So if we can find the area of one of the triangles, then we can find the area of the entire thing. All right. So we know that the base of the triangle is 8, but we don't know the height, which is essentially an apophthegm. So what we're going to do is think about the fact, since there are 6 triangles in the top of our hexagon, then we're going to take the 360 that they all come up with, or add up to, and divide by 6. So each of those top angles is 360 divided by 6, or 60 degrees. So this whole top angle is 60 degrees, which means that the smaller angle is 30 degrees. We want to find the height of our triangle. And we know that this short side right here is 4. So you can either use a 30, 60, 90 triangle, or you can use a trig function to do this. If you use a trig function, you would say that the tangent of 30 degrees, the tangent of 30 degrees is equal to 4 over h. Then we would multiply by h and get h tan 30 equals 4. So the height is 4 divided by the tangent of 30, which comes out to 6.9. Now that we know that our height is 6.9, we can find the area of one triangle. This large triangle, well, to find the area, we do 1/2 base times height. This large triangle has a base of 8, because we're looking at the whole blue triangle, and a height of 6.9, which gives us an area of 27.6. Then the area of the hexagon is the triangle times the number of triangles, which is 6. So our final area is 165.6 centimeters squared. This then gives us a formula where essentially we can do the area is equal to 1/2 the apothem times the perimeter. So A is the apothem and P is the perimeter. I like just finding the triangles and working from there. I think it's a little bit easier. So whichever way you'd like to do it is fine. All right, let's take a look at number 1. Right away we can find our perimeter. It's 6 times the number of sides. 8 sides. So 6 times 8 gives us a perimeter of 48 centimeters. Now, to find the area, we'll draw in one of the triangles with the radii. And then I'll put in our height or the apothem. We know that the base is 6 centimeters, and each little piece will be 3. We want to find the height, so we need an angle. So we're going to do 360 divided by 8, and that gives us 45 degrees. So the whole top angle is 45 degrees, which means our smaller angle here is 22.5. Now we can definitely use trig. We certainly can't use a special right triangle, and say that the tangent of 22.5 is equal to 3 over the height. Then we multiply both sides by the height. So h 22.5 equals 3. So our height is 3 divided by the tangent of 22.5, which is 7.2. Then we can find the area of the triangle. So that's equal to 1/2 times the base of 6 times the height of 7.2, which comes out to 21.6. And then the area of the octagon is equal to 21.6 times 8, which gives us a final answer of 172.8 centimeters squared. If we had wanted to use the formula, then we would say 0.5 times the apothem of 7.2 times the perimeter of 48. When you type that into the calculator, you get exactly the same answer. All right, I'm going to add one more slide so that we can look at example number 2. Example number 2 is a decagon. So we have 10 sides. But what we were given was a radii of 12. So we're going to need to do some work to be able to find the perimeter and the area. Just like always for the area, we need to find the height or the apothem. So we'll divide 360 by 10. That gives us 36. So our large angle is 36 degrees, and the smaller angle is 18 degrees. Then we put our height on here, and we use trig, but this time, based on that 18-degree angle, we know that we have to use cosine because we have the adjacent and the hypotenuse. So cosine of 18 degrees equals h over 12. Multiply both sides by 12, and our height is 12 times the cosine of 18 degrees, which when you type into the calculator is 11.4. And normally at this point, we would go ahead and find our area because we knew our base. We knew the bottom of the triangle here. This time we don't. So we'll call this x, And to find x, we're going to use trig again, this time for sine. So the sine of 18 degrees is x over 12. X is 12 times the sine of 18. So half the side length is equal to 3.7, which means a side is going to be double that, so we multiply by 2, and we get 7.4. Okay, so now we can find the perimeter. The perimeter is going to be the side of 7.4 times 10, or 74 centimeters. The area of the triangle is going to be 1/2 times the height of 11.4 times 7.4, which gives us 42.2 when you round, 42.18, but rounds to 42.2. So then the area of the decagon is 42.2 times 10, which is 422 centimeters squared. All right, let me know if you have any questions.